Okay, right. So last time we were mucking around with Pythagoras' theorem, and we observed that this triangle here, 3.277, I'll zoom in a bit. It was this one here. Right angle 3.277. That was 4. And what was the other one? What was the other side there? It was this one here, 2.294, wasn't it? 2.294. And up to numerical accuracy at least. This kind of verified. So this is a verification of Pythagoras' theorem. Pythag. There it is. It's really nice, that. Of course, it should be a nice, neat triangle. But it's a bit difficult to draw on this little tablet thing here. Right. Okay, so why is that true in general? Let's just see what I'm trying to say with this. If we go back to our original, let's try again. There it is. There's theta. There's O. There's A, and there's H. Now, let's just think about what Pythagoras' theorem says. What Pythagoras' theorem says. What Pythagoras' theorem says, Pythag, says this. It says that O squared plus A squared equals H squared. I know we've said A squared plus B squared equals C squared. I'm just using different letters. Oops, that's my right angle. So what I'm going to do is take this equation here and I'm going to divide by H squared. I'm going to divide both sides by H squared. Why? Because I feel like it. So we've got O squared plus A squared divided by H squared equals H squared divided by H squared, which is great. Which equals 1, of course, because it's H squared over H squared. What's the left-hand side? Well, that's O squared over H squared plus A squared over H squared, which equals 1. Because all I've done is expand out that top bracket there. And I'm going to rewrite this like this. You see, it's O squared over H squared, so it's O over H all squared plus A over H squared equals 1. Go back to my triangle here, which I'll draw again. Forgotten my bracket, haven't I? There it is. There's theta, O, A, H. We've got this relationship here following from Pythagoras' theorem. Now, you'll remember what I said about O over H. It wasn't the last screencast or the one before. I think it was the one before that. O over H, opposite over hypotenuse, equals sine theta. So we can write that as a sine theta, but it's all squared, you see. And A over H equals cos theta, which is that over that, which is this bit here. So I can take that, which is O over H squared, plus A over H squared equals 1. And I can use these definitions here to write it as sine theta squared plus cos theta squared. All I'm doing is writing A over H as cos theta equals 1. And because of the way I've set it up, it's true for any angle you might name. When you see this in the literature, you'll probably see it written like this: sine squared theta, it's the same thing, plus cos squared theta equals 1. And when you hear professionals talk, they'll say sine squared plus cos squared equals 1, without even specifying the theta. Well, that's nice. That is quite a nice little piece of reasoning, That's a nice little theorem. So I'm going to verify this. I'm going to try with theta equals, let's say, 26 degrees. Why 26? Because I feel like it. Okay, well, I'll better go to get to my trusty old calculator, which is here. 26 degrees. Sine is there. And again, I've got all these huge decimal places, but I'm not going to bother with that. I'm just going to write down the first 3 of them. So sine theta equals, I've forgotten already, bonk, 0.438. So sine theta squared equals, well, it's that times itself. And I can do that with this, I can do that with this button here. Junk. 0.192, just say 0.192. 0.192. So we've done half of it already. There you go. What else have I got? Oh, we want to work out what cos theta is now. Cos theta equals, with theta equals 26, 26 cos. There it is. Look at this, 0.8987. So it's 0.899. 899. And so cos theta squared, which I would normally, if, oops, I've written sine. I would normally, if I was working on this, if I was in my research, I would do cos squared theta, because that's how you do this sort of thing. Equals, well, 0.899 times itself. So I'll just square that. There it is. 0.808, let's say. 0.808. So what's sine squared plus cos squared? Sine squared theta plus cos squared theta equals 0.192 plus, from here, from here, plus cos squared theta, that's sine squared theta, and plus cos squared theta is this, that one there, 0.808, 808, and it should be 1. Okay, so 8 plus 2 is 10, 0 down 1 to carry. 9 plus 1 is 10, 0 down 1 to carry. 8, 9, 10. 0 down 1 to carry, 1. Ha! Sine squared plus cos squared equals 1. And it happens to be exact, but of course these are only to three decimal places. So you'd expect a bit of rounding error, but that's not occurred here. Well, that's nice, isn't it? Sine squared plus of any angle, theta, plus cos squared of any angle equals 1. And that is basically the trigonometric equivalent of Pythagoras' theorem. And it's really, really useful because you remember when we were coming up with this this stuff here, we used sine to work out the opposite, because we used this relationship here to work out the opposite. Given the hypotenuse, we knew that was, I think it was 4. Yeah, there it is, 4. Doesn't matter what it is. Given the hypotenuse, we use sine of this angle here to work out the opposite, and we use the cosine to work out the adjacent. And I needed to use the calculator separately to do these two functions here. But with this relationship here, sine squared plus cos squared equals 1, we don't need to do that because we know we can work out one from the other one. Look, watch, I can say that cos squared theta equals 1 minus sine squared theta. So that tells me that cosine of theta equals the square root of 1 minus sine theta squared. How long have I been going? Oh, this has been going too long. I'm going to have to stop here. All right, stop.